Welcome to this video on Introduction to Significance Tests. By the end of this video, you should be able to state appropriate hypotheses for significance tests about a population parameter. You should also be able to interpret a p-value in context and make appropriate conclusions about a significance test. All right, so today's scenario is, am I a good free throw shooter? All right, so I claim to be an 80% free throw shooter. So to prove my skills, I shot 50 free throws and I made 32 of these shots. Am I exaggerating about my free throw skills? All right, so first let's start off by identifying the parameter, the population, and all of that. So the population would be all free throws shot by me. Okay. Our sample here is, I took a sample of 50 free throws. Okay. The statistic, we got a sample, so a p-hat of 32 out of the 50 made it, for a percentage, a free throw percentage, or probability of 0.64. So our parameter is, we want to estimate the true proportion of, I'm going to say FT for free throws made. So now in reality, what has happened though is I have made a claim. I have a claim that the population parameter here is 0.80. This is my claim. Okay. So we don't know that that's what it is. That's just what's being claimed. So there are two possible explanations of why I made 32 out of the 50 shots. They are either I am a 80% free throw shooter, but I had a bad day, or I am not an 80% free throw shooter. So either I am an 80% free throw shooter and I had a terrible day, or I am not a free throw shooter. That's pretty much our choices. Okay? So what this leads us to is hypothesis. So in science, there's null hypothesis and there's alternative hypothesis. So in our stats class, the null hypothesis, so N-U-L-L, null hypothesis, means nothing different. Null meaning zero, zero different. So there's nothing different from the claim is really what they're saying. Okay. And then we have an alternative hypothesis was, well, what else could it be? So here's how we're going to write these. You're going to use H for hypothesis, and for the null, you're going to H sub 0. So if nothing is different, I claimed an 80% free throw percentage. So what I'm going to say is we are talking about a population proportion, so I'm going to use P. My null hypothesis is my claim of 80%. Okay, we're not saying it's right, we're not saying anything like that, we're just saying this is the claim. Okay, I have an alternative hypothesis, so again we're going to use H for hypothesis, and you're going to use an A to denote that this one is the alternative. So I'm actually, instead of equals there, I'm going to just turn those into dots. We'll use those as semicolons there. For the alternative, we're still talking about a population proportion, but in our sample, we got a number that was less than the claim. So we want to see how likely is that. So we want to know what's the probability of being less than this 80%. Okay, so this is our null. And this is all our alternative. And you can refer to them as the ho and the ha. It helps you kind of remember them. Okay. And we say less than right here because 0.64 is less than 0.80 of the claim. So 80 is the claim, 0.64 is the p-hat. All right, so to test my claim, if we assume that I am an 80% free throw shooter, okay, so this is our null hypothesis. You're assuming I am an 80% free throw shooter. Let's examine the likelihood that I will make 32 out of 50 shots through a simulation. Okay, so I used a spinner and I performed this 50 times. So I labeled 80%, so 1 through 8, where I made it, and 9 and 10 I missed it. So I would just spin it and count out of the 50 times how many I made it. Okay, so this is where my numbers came from, as I just used this online spinner. All right, so I collected all of our data for us, and here's what I got. All right, so here's the results of my 50 trials. Okay, now, how likely is it that my claim is true? So if I am an 80% free throw shooter, is what we're assuming here, because we set up the spinner to be an 80% free throw shooter. The results I got in our sample occurred, so there's our 0.64, only one time out of my 50 trials, for a probability of 0.02. So what does that mean? Let's flip this over and find out. All right, so before we begin finding out some information about what our results meant, let's remind ourselves, what does each dot represent? Remember, each dot represents the proportion of free throws made in a sample of 50 free throws by an 80% shooter. So in here we've got our context because we're talking about free throws. We talk about our sample size because that would be kind of important. And then we're making note by an 80% shooter because our spinner was set up that 80% of the spinning spots were a hit while 20% were a miss. So we wanted to make note of that. So one student says, each dot represents the proportion of free throws made out of 50 free throws shot by Dr. H. Is that correct? It's not, because we don't know that I am a 80% free throw shooter. I am claiming to be an 80% free throw shooter, but we do not know that for certain. But we know that the spinner was an 80% free throw shooter because that's how we set it up. Okay, so it doesn't represent me, it represents an 80% free throw shooter. So now let's go on to number 8. What percentage of the dots represent a percentage of 64% or less? So we've been really doing this the entire course. We did this on day 1 and have been doing it a lot since then. So we got a p-hat of 1 out of the 50 simulations had 64%, which was what I actually made in our p-hat. So that gave us a 0.02. Okay, now what does this actually mean? So what this means is assuming that I am an 80% free throw shooter, because that's what we were assuming when we set up our simulation of an 80% free throw shot shooter. There is a 2% probability that I make 0.64 or less of my free throws purely by chance. It's possible, but in 50 samples, this result only happened 2% of the time. Okay, so it's showing that it's pretty unlikely, and the purely by chance, because we used a chance process to simulate this. A spinner is purely chance. Okay, so purely by chance, I could, on a bad day, get 64% of my free throws. But after simulating this over and over and over again, it seems unlikely that just chance got the 64%. So what we really have is we have evidence that I am exaggerating. And we think I'm exaggerating because we've been doing this the entire course. 2% is less than 5%, meaning it's unlikely an 80% actual person who can shoot 80% would perform that poorly based on our simulations. Okay, so there's some evidence that maybe I'm exaggerating my abilities just a little bit. So let's talk about a couple things here. This value up here that we got from our sample, we are going to call this a p-value. It's the probability value. Okay, so we're going to be talking a lot about p-values when we're doing our significance tests. Now when we interpreted this part right here, the assuming that I am an 80% free throw shooter, that's actually my null hypothesis. Okay, that's what I stated when in my null hypothesis. That's my claim. Okay, and then we made a conclusion based on this interpretation, and our conclusion was that I was exaggerating. So we're going to have a conclusion. Okay, so that's going to start building into our 4-step process. Now you've already done this along the way. We have taken where we've gotten a probability of an event and compared it to 5%, a lot, for the entire course, and we would determine if something was unusual or not. So we used a chance process to run our simulation and found it to be unusual, and that means we have evidence against the claim. There's something weird going on. We don't think it was just a bad day because it's so unlikely to happen just by chance. We think something else is going on. All right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.